Today we're going to talk about the graphs of quadratic functions and finding the vertex of a quadratic. So first of all, before we get to the vertex, I want to talk about how you know whether a function or a quadratic is open up. You notice I've got the word up there because the up looks like a U, or whether it's open down, in which case it looks like an N, at least a lowercase n. So you can actually just look at an equation and tell if it's open up or open down. Well, if you look over here, I have the general form of the quadratic equation. ax squared plus bx plus c, where a, b, and c are constants. In other words, a, b, and c will have numbers. Well, it turns out if a is greater than 0, then you open up. And if a is less than 0, then you open down. So another way to say this would be, if your x squared has a negative in front, you're open down. If your x squared has a positive in front, you're open up. So you can very easily just look at that and tell if it's up or down. So for example, I'll just put some in the calculator here for us to look at. Let's say we have 2x squared minus 6x minus 3. Okay, I need to add my minus in there. There we go. Okay, so there's my equation. I can look right here and see that I have a positive number in front of x squared. And that immediately tells me that I should be open up. And I am, shaped like a U, shaped kind of like an umbrella, or an upside down umbrella, I guess. Never mind. Shaped like a U. That's open up. Now, if all I do is take that and I change it to a negative 2, then it's going to open downward instead of upward. And you can see that there. So up when the x squared has a positive number, and down when the x squared has a negative number. Okay, now the vertex is this point I've marked right here. That's the vertex. If you notice, when you're opened up, that's the minimum, and when you're opened down, that's the maximum. So the vertex also corresponds to either the maximum or the minimum of the quadratic, depending on whether you're opened up or down. So to figure that out, you can get the x value of the vertex by doing negative b over 2a. So I'll just pull up a random one, 5x squared minus 6x plus 4. We know that our a is the number in front of x squared, our b is the number in front of x, and our 4 is c because it's the number all by itself. So to find the vertex, we need to do negative b, so that'll be negative 6 over 2a, which is 5. So we get positive 6 over 10, or 3/5. So our vertex for this equation, 5x squared minus 6x plus 4, is at x equals 3/5. Now if I want to find the y value, all I have to do is plug 3/5 in the equation, and that will give me the whole ordered pair. So let's go ahead and do that with the next example. It says y equals x squared plus 4x plus 7. So first of all, we ask ourselves, does this open up or down? Well, again, the key is the x squared. You look and see, is it positive or negative? Well, since the x squared has a positive number in front, there's an understood positive 1, it opens up. So I'm just going to draw that over here so we can kind of get a visual on what that would be like. Now the second question is, where is the vertex? Now when they ask that, you should assume, unless they say otherwise, they want the whole point. They want the x value and the y value. Well, we know we can find the x value by doing negative b over 2a. Now my a is an understood 1, my b is 4, and my c is 7. So I do negative b, so that's negative 4, over 2a, that's 2 times 1. So I get negative 4 over 2, which is negative 2. So that's my x value. Now if I want to know my y value, probably the simplest way to do this is to just plug it in. Y equals x squared plus 4x plus 7. and then go to my table, because my table will let me plug in whatever number I want. So I need to plug in -2, and I see that I get the point -2, 3. So my vertex would be at the point -2, 3. Again, I got the y value, the 3, by plugging -2 in for all the x's and solving. So my vertex for this is at the point -2, 3, and their question is this a maximum or a minimum? Well, if you know it opens up, you should just be able to look at it and tell. Clearly, with the picture I've drawn, -2, 3 is a minimum. Okay, next example. Y equals 4 minus x minus 2x squared. It says, does it open up or down? Now this one's trying to trick you. They've written things in reverse order. They put the c first, then the b, then the a. But a is always what's in front of x squared. So if you look in front of x squared, we have a -2. Since we have a negative, that means it must be open down. So our picture looks like this. Then it asks us to find the vertex. Okay, well what I've circled already is our a, and understood -1 is our b, and our c is 4. So we get x equals -b over 2a. That's -1 over 2 times -2. So we get a +1 over -4. So -1/4, we'll just leave it that way. -1/4 is our x value. Now we get our y value by plugging it into that. So let's just do that a more normal way perhaps. Just plugging in -1/4 into our equation. So 4 minus -1/4 minus 2 times -1/4 squared. And we get 4.125, or if you want the fraction, it's 33 over 8. So our ordered pair would be -1/4, 33 over 8. And that is our vertex right there. The last question is it a maximum or a minimum? Well, again, if you just look at the picture, it should be very clear to you that this is a maximum. It's at the top of a parabola that's opening down. Last example, -x squared plus 4x minus 1. Even though they don't ask me whether it's open up or down, I find it really helpful to be able to go ahead and draw that picture of it either being up or down. So I'm going to go ahead and look here and notice that that's a negative in front of the x squared, so I must be opening down. Now my vertex I know is -b over 2a, and my a is a -1, my b is a 4, and my c is a -1. So I get -4 over 2 times -1, so -4 over -2 is 2. Now to figure out the y value, I need to plug 2 into that equation. So I get negative parentheses 2 parentheses squared plus 4 times 2 minus 1. And we get a 3. So the ordered pair would be at 2, 3, which is right here on the vertex. The last question is it a maximum or a minimum? Again, if you just draw the picture like I have, it should be very clear that it's a maximum. Now just so you know, they may not ask you all of these questions. They may just ask you one. They may just ask, is it opening up or down? You just look at the x squared. They may ask, where's the vertex? You'd use -b over 2a, then plug that answer in the function. Or they may just ask, where is the maximum or the minimum? And that's where you're going to have to remember that maximums and minimums happen at the vertex. And you can figure that out by finding the vertex, seeing whether we're open up or down, and then running those numbers.